I don't think I'm in the ideal shape to talk about resiliency, but we'll try. Thanks for giving me, I would like to thank HPC Advisory Council for giving me this opportunity to give the first technical talk of the session. I was a bit nervous. It's not that it's the first time I gave technical talks at the HPC Advisory Council, but it's the first time I'm giving the very first talk. And I thought when I put together the title and the topic, I am really interested and excited, and I would like to engage you to talk about resiliency. But it's not a typical topic here because it's HPC and P is typically for performance, depending on political pressure or any other thing. Sometimes it's for productivity also. Let's check with Gilad. Is P here for productivity or performance? Sorry to put you on the spot. Let's go with performance. Productive performance. Well, yeah. But as I would like to maybe convince you that resiliency is really an integral part of productivity and performance, or performance and productivity. And because the focus here is, among other things, on the interconnect or networks, I would like to talk about how network is an integral part of all the systems and services we operate in a data center. So I feel this is the right moment, right time, right community to really focus at resiliency from a service-oriented way. And I'll talk in a bit more detail later. And in addition to welcome from Gilad, Brian, and Hussein, I would like you to welcome also on behalf of CSCS. Just like a quick survey, how many of you have attended all HPC advisory councils? Okay, I'm so proud. Torban, okay, next. All right, how many of you have attended more than one? That's pretty impressive. Okay, so I mean, it shows that in addition to the organizer, there are people who like coming back and they see the value in there. I'm not going to ask sponsors because the message could be different if you ask sponsors if they are coming or not coming or they're every year, but I would also like to thank sponsors, as Gilad says, that this event couldn't be possible without them. And over these years, and maybe before that, when we started looking at interconnect, and mainly I talk about from an InfiniBand point of view because I was mostly myself interested in the HPC performance aspect, and the presentation in previous years were mostly for me around the topic of GPU or accelerator-based computing and interconnects. Now what we see is, as in my role also at CSCS, I see a bigger picture, is about, not about interconnect for HPC systems, it's about all the systems and platform and services that are interconnected. And I'll show you some of the figures that some of my colleagues put together to show you we cannot really look on a component by component basis, but we have to look at a holistic approach when we talk about resiliency and, among other matters, performance as well. And the other thing I would like to highlight about the advisory council is over the years, okay, there are some basic topics like interconnect and system administration for interconnects and networking applications. But, and I have done a little bit of a survey in my presentation. You will see the program has adapted depending on community and user needs or attendees needs. And in fact, maybe next time when you give an overview, Gilad, of HPC Advisory Council, you could highlight that. I think it's an strength. And then I say, yeah, I knew that the next 2 days may not be, from a weather point of view, ideal being in Switzerland or in Lugano. I should be specific, but it's usually very nice, as you can see from this picture. So it doesn't mean that you should skip today and go out, because the next 2 days you will be in. I hope the program is nice enough for that. A little bit, although we have some returning attendees, I would like to say a few things about CSCS, and especially what has happened over since we had the first HPC Advisory Council meeting. So the mission of CSCS is to provide, develop, and promote technical and scientific services, and we will focus a little bit more on services in subsequent slides for the Swiss research community. So we have a user lab program for the users who can come and use compute, storage, visualization, data analysis resources. But in addition, we have customers and partners who either host or house their resources with us, and some depend on some of our basic infrastructure and some don't. So the picture, if you go on CSCS website, it shows this view of, you can see the tape library in the building, which is of course fundamental to a data center, and of course the high-end system, our flagship systems. And since 2012, CSCS has moved a long way. There have been many interesting events and things that have happened. So I would like to highlight a few things. The most important thing for a service-oriented organization, or as we moved towards a service-oriented environment, was having applications, investment in applications to take advantages of resources. So there was this project called High Productivity and High Performance Computing, where projects all over Switzerland were funded to accelerate or invest in codes to exploit the next generation HPC resources. This project later became the PASC platform for advanced scientific computing. And from 2009-2010, we have had investment together with applications in test beds and resources. And in fact, for me, HPC Advisory Council became really valuable, because that's where we started sharing experience and knowledge about this GPU direct technology, meaning that you can communicate directly from a GPU over the network, and PI is enabled. And as a result, not only in our InfiniBand systems that have accelerators and GPUs, but also on Cray system, when they came online, they have had this feature available. So we have some applications also they use it. So we have the feature available in all the way from system and PI and application level. And I think the discussion, info exchanges at this event was really fundamental to that success. Alongside, we had launched many other services, so I'm not going to go line by line at every item, but the message here is CSCS, as HPC Advisory Council has been growing over the years, CSCS has been. And one thing is, I think it was in 2012, the move of CSCS from Mano to Lugano coincided with the Advisory Council, and I think some of the attendees were the very first people visiting the Bayer facility. And I don't know, we are not planning on any site visits, but if someone is interested, I think you can talk to us. And in case someone was wondering who is that person in that picture, so that's Nicola Bianchi. So the idea for the talk I put together that because I wanted to really talk about resiliency. As I say, I see a bigger picture, so I want to talk about why it's important. But the technical elements came from, and the results and data came from a lot of people from CSCS. And the reason I put their faces and names here is mainly because some of them are here. So if later in the next couple of days you would like to talk to them about some of the details, find them. I think their pictures are fairly recent, so you should be able to recognize them. And they provided me input or technical material, but I won't be able to go into a lot of detail. And there, I will show these names and things like that. So before moving forward, I would like to highlight this service-oriented concept that we have been implementing at CSCS. I'm sorry, it's a kind of a busy slide, but the idea, what we've been working on in past 2 years is, rather than building one system for HPC, one system for visualization, one system for data analysis, we are building a consolidated system and provisioning multiple services on those systems. So just to give you an idea, so PISDYNE, which is our flagship system, is a Cray XC40 with the GPU devices. We extended it. It shared the file system resources with an Haswell-based Cray XC40 system, where we put large memory nodes in there. And what happens is, when we decommission our standalone visualization cluster, the GPUs in the PISDYNE are now being used for the visualization software or services that were run on our a standalone cluster before that. So rather than buying another resource, we were able to offer a resource in an existing and many, many times bigger system. So now we have several projects looking at how they can use these over 5,000 GPUs in some of more exotic ways than they were before. It doesn't mean that these GPUs are not used for HPC, of course, that's for the main part. But because you have a high-speed interconnect in the system, you have really high and powerful GPUs, and then you have a very powerful scratch file system, the potential for some of these data analysis and visualization resources for user is tremendous. At the same time, we have storage. GPFS is sidewire storage. HPC storage, which is more system-oriented, is mainly Lustre. And then we have all. And then I would also highlight that the services, some of the basic services that are shared with multiple users and user lab, but CSCS also has specific housing and hosting services for some of our customers and contractual partner. For example, in case of Meteosys, for the weather forecasting, we have an XC6 system. Then we have, for the grid community, the Phoenix system, and then the Blue Brain project. And we have also offer services to Hilti customers. And this is by far not the complete list, but it covers most of it. So now, because I already used 1/3 of my time, I would focus on the main topic, which is resiliency. The reason this Slinky is there, because if you go on Google and type resiliency and look for images, that's the first thing that comes out, which probably makes a bit of sense. But let's see. So I will not read through the definition, but the whole idea is that the ability to become strong, and then the ability to return to an original state is the idea that you design resilient systems so you can rely on a service that is there. And then, of course, it's a dictionary definition, and then I said, okay, can we have an example in an HPC environment? And the reason I highlight dynamic is because in HPC we just don't build, let's say, a Slinky and leave it like that. You constantly evolve hardware or hardware extension, the software changes, user or system software changes, you have to patch the system for security. So a lot of things happen which can have unintended impact on the continuity of service. So overall, what's important is, or the target for us is robust operations. So at all time, we would like to maintain robust operations for the users and customers. And if something bad happens and something changes, we would like to resume services, because end of the day, users rely on services. They really do not care which part of the system or software is broken. So this is kind of the goal for us in a data center environment. So it's not a new topic. I mean, I'm not going to suggest that somehow that suddenly, and if you look at the systems around, not only in CSCS but all across hardware, software, resiliency is there built in at different level. So one of the first thing people do is, especially for high availability solution, is redundancy. And then I say, okay, it is very useful on a component level, but in the true statement, should we look for 2 or more pulse dyne to have it available if something goes wrong with one and we have another one? Of course, this is not possible, but that doesn't mean that there isn't a resiliency, built-in resiliency at different component level in the system. Failover, this scheme is always used. And for high availability solution, we have this system in place, also in storage and network and other solutions. So it exists, is there, and it's available at different component level. Fault tolerance at the software level, I think fault tolerant MPI research has been going on for more than a decade, if not 2. So people are looking at these concepts for a long time, both in terms of system design as well as in software design. Another way of looking at resiliency or resuming services to user, different sites can think of, or data center or sites can think of on-call services. CSCS has one. So it's more human-oriented. Of course, there are systematic alerts and monitoring, but when something really goes wrong, and depending on your SLA and other requirements, you may set up this on-call service to resume operation. And service migration. So these concepts are maybe more commonplace in a cloud environment, but in an HPC environment, because we tend to couple our applications or workflows very tightly, this is not being used as much here, and we can look at it. But the bottom line is, of course, we want as much resiliency as possible, but it comes with some cases with a huge cost. And from the system conceptual to design and operation, one of the things that keeps coming back and that we need to consider is cost effectiveness. So all these things I mentioned there, they involve some level of redundancy or fault tolerance, but at the same time you have to think of the cost, not just the procurement cost, but also the operational cost. Very quickly, because I mentioned CSCS on-call, so we operate in 3 different levels. Red is for system which highest availability 24/7 requirement, and then we have orange system mainly for central services. So red systems are decoupled from our central services and other main systems, and then the green systems are. So you can talk to my colleague Carmelo if you want more detail. The topic I want to focus on is what should we do different, or why I want to look at it right now here in this community. So what are the dimensions? So how we look at resiliency in a data center, service-oriented data center environment. The basic concept is everyone wants resilient services. So from a user point of view, as long as they are running and happy doing whatever they are doing, it's they are and services that are available are up to date, they are happy using. From an operational, I will go in detail about the exact requirements or output for these 3 dimensions later. For operational environment system, people who operate system, if the systems are not generating errors or alerts and everything is green, they are pretty happy. For stakeholders, of course, it could be customers or it could be people who invest in resources. As long as they are getting value for their investment, they are happy. The thing we will look at it later on, it may be possible that a service or concept or perspective of these resilient service may not be identical from all these point of view. It may be the case from an operational environment, everything is fine and dandy, but a user is really, really unhappy because the software update he or she was looking for isn't being applied, and the system people are thinking, I'm not going to apply it because it might break or make system a bit unstable. From a stakeholder point of view, they want, for example, fewest downtimes or more and more application being done, but these requirements can contradict with the requirements by other things. So overall, it will be a compromise or a discussion, so we cannot just look at resiliency from one point of view. That's the point I'm making. Here I create some hierarchy or hierarchical building blocks. I created it mostly based on CSCS. It doesn't reflect our organizational structure, but maps pretty well. And I think fundamentally it may be similar to other data centers or service providers. So basic item in a data center, you have a power, cooling, or facility infrastructure where you house resources and system. In fact, when things go wrong here, pretty much all bets are off. Then on top of that, there are basic services like network authentication based on hardware and software. They have to be available before people can start running or using resources and services. At CSCS, then we consider what we call shared resources like site-wide file systems, for example, or HPC interconnect that is shared by multiple systems. Then we have, for example, our main system, Cray, or some other HPC cluster. And the other environment are pretty much software or user focused, where execution environment to me may be a job scheduling system also in addition to compiler and other. And then user applications and services. So when I look at it, changes happen all the time. But typically, the rate of change or you can think of people who have a very conservative outlook. It's probably, you will find them here than here. I mean, it's maybe too much of a generalization, but the investment needed here could be more than investment needed maybe at other level, and that's why typically, I won't say always, but typically rate of change is lowest here versus in an HPC center like CSCS, where you have a variety of user using resources, you can have a lot of more changes coming or happening here that may or may not affect all the way. So the idea here is services are built using a stack. You can have another view, and in case of a resiliency, it's not every so often that a user application change here can impact things here. It should not happen in theory. There should be built-in resiliency. But we have to consider, in terms of designing resilient solution, that we do not leave an important building block out. So in addition to perspective, what we really have to look at is what are the dependency in my data center? And they may vary from a data center to other, but it cannot be fundamentally different from this hierarchical. So very quickly, so users at CSCS, of course, one of the main reasons they come and use resources because they are interested in scientific insight, and they go on then publish papers in journals. And there we have publication lists that are reported by users, and some are. Then we have our customer, the weather forecasting, reliable weather forecasting is very, very important. And the requirement here could be fundamentally different from requirement here. In fact, I would argue requirement for users, because a user working part of a user lab project may be doing production simulation, but at the same time they may be building new software, and for that the rate of change here for them is going to be, so someone running production level simulation, they don't want anything to change, but while someone developing software, they want new version of, for example, CUDA every time it comes out. So if it is not the case, the person who is developing a new application, for them, the services are not there or not resilient because they cannot adapt to changes that they need. Operational staff, I put some of these charts here that show health of system. So ideally, fewer changes are better, but changes happen, and they do happen for many, many reasons, and they have to adapt so that services are available for the user. Our stakeholders, they are usually happy if they see a variety of scientific domains are using our services. In some cases, they may or may not be happy because of system up or down times, which we may or may not have to, we usually have to take because of maintenance to keep up to date or with other requirements. So it's a complex picture, but we cannot say that the resilient services should be driven by one dimension. We really have to look at all of these things in together, and there is a solution. I will come back to it. But before I do that, what I did is I called it unscientific survey because I just went to the HPC Advisory Council website there. So I think the first, and if there is any error, I apologize. So the very first one happened in 2009, I think in China, that's correct? Okay, and over the year it grew, so I didn't have the latest info, so that's why it's ... here. And the interesting thing, I mean, the first thing I noted was in the very first year, there was a talk on cloud. Even in 2009, and GPUs were introduced. So over the years, some topics then kept coming back in. Some came once and then they were not repeated, but mainly accelerators and now big data are always almost part of the program. Resiliency has been there as part of system storage and file system and network management, but data center resiliency has not been, or services resiliency has not been addressed from a network point of view so far. So what I could say, maybe Brian or someone, you can do do this search where you look for keywords, and the keywords that get repeated in titles or abstract, you can highlight and create that. Which topics are the biggest draw versus which ones are not. So what I will do now is just give you an idea of CSCS, how integral is the InfiniBand and the network to all the services we provide. And this is a very high level picture. Chris simplified it for me many, many times over. So right now it looks all dandy. In fact, this is kind of a strange thing because our HPC system, which are depicted in a Cray design here, our Cray systems internally, they have a different high speed interconnect, which is not InfiniBand, but the storage systems are InfiniBand. So these are other HPC systems that are on the same network backbone. Storage is connected. There is a redundancy here, as you can see, subnet manager, and then there are other compute nodes for various services. So the picture is simple, but as I will show, especially for the storage environment, this thing can go down, and as you go down, the complexities and dependencies increase. This is the network setup. I will not spend more time because otherwise I will run out of time. This is our GPFS. So here, this is the paper that was about in 2002 written. The basic infrastructure hasn't changed, but the way you deploy and commission it for a center like CSCS, it can be very complex with distribution of data and metadata, and then the connection you see internally could be fiber channel and other. Some cases we have direct GPFS clients, and some cases we have CNFS. So if everything works, it's all fine. And in theory, GPFS can handle node disk and communication failures. I put a star here, and I would encourage you to talk to Stefano, because recently what happened was is in a very routine upgrade, we have had I should call it a lot of excitement, unintended, and we are. So you should talk to, because that kind of, for me, was one of the reasons I wrote this presentation like this. So what do we do? So to improve on resiliency, because so far I talked about how complex it is, there are so many dependencies, we have to worry about users, stakeholders, but solutions are usually very simple, because HPC, okay, it's complex, but it's not too complex compared to many other organizations or industries we think about. And it all boils down to simple ways of looking at it. So you can have a bottom-up or a top-down solution. What is bottom-up? Bottom-up is when you have a problem, you have an organization, you have a situation, you find a solution. So see, at CSCS, we started building regression testing tools, and I will show a little bit about it and the reason. People, for a long time, they have monitors, alerts, log file, depending on, and as things happen, when some really bad accident or you have a big failure, you end up writing a workaround or solution around it. So it's more sort of homegrown or need-driven. And it works. I mean, most data centers are up working and providing services. Another way of looking at it is, I can say, is top-down. And in these cases, these approaches are standard-driven. So here I put this figure. I will not go into detail because I am by far not a facility person. But what has happened is that depending on the design requirements of a data center, you could have a tier 4 versus a tier 1 data center. And if you look at into detail, the notion of redundancy and uptime can vary significantly from the top tier and to the bottom tier. And what can happen is, rather than you figuring as a data center figuring out how should I do this, that you go and look up at this requirement, and then you do your architecture and design based on that. So we can think about like that for data center resiliency in a service-oriented environment. We don't have it like such a standard right now, and what I would propose today is more of a community-driven effort for a HPC service-oriented community, and then we can work around it. And as I said, a holistic approach is going to be a combination of both. So there is not going to be everything covered by a standard, and based on a custom site and a custom requirement, you have to adjust and adapt. But at the same time, especially when we work in a federated environment, it's good to have some top-down approaches. So CSCS regression, so it came about because one of the main problem we were struggling with is when we installed PISDINE, it was the first Cray XC40 system with GPU devices at that scale. So we were the very first site experiencing issues and problems in a very complex manner which were not being experienced before. So we came up with that. But now if I look at, now I have a bigger picture of the center. So what I look at is what could happen and what would be the best way to approach is rather than coming up with a big suite, you can maybe start and thinking of these layers as, I'll call it customers and service provider. For example, if I look at it this level, user applications are customers of programming and execution environment. So users write regression suite, or I can consider it a contract. So if I am changing programming and execution environment for any reason, before I say successful and resilient, I have a set of testing tools that are, rather than me guessing what users may or may not run, they will be a contract that these two decide between themselves. The other way of looking at it, and it came to us for this GPFS and network problem. So rather than the network person deciding how should I test all the GPFS based needs and dependencies, the GPFS team or people who are responsible for running GPFS services, they can come and write a set of tests and tools which independently can be run by network team. So in that way, you do not create tight coupling and dependencies, but at the same time, you have a way of letting other side establish one of your hierarchical service on which you will build on other service. So if I look at the CSCS regression suite right now, it's composed of some of these components, but there are other components which may go all the way. And there are some tests, for example here, if more cases, if something fails here, we may not need to run all the other ones. And just to give you an idea how the workflows goes here. So there is a driver, it's a custom written one, and then there are admin checks. And if they fail, okay, all bets are off. And then there are application checks, because you can run regression day in and day out, but you have to return services to the user. So when we do these things, we set a time limit, and usually in that time limit, you try using the tests that tell you most about the health of the system. So admin tests, of course, you need them, because if some basic things are not working, you cannot open the system or return services. But you very quickly go to application level tests, because applications touch so many different parts of the system in so many different ways. So there are other ways about learning health of systems or services there. And in the interest of time, I will not really go into detail, but and I would encourage you to talk to Tim or Gabriella. These slides are from Gabriella. That you can run them as part of a normal maintenance and operation, but these things can be invoked if there is a concern that some service is being not fully functional or operational, or you expect a failure in hardware and software. So I will move through quickly. These are just the output, how you interpret it. And the good thing is, now it's been written in a way that the test can be independently run by even people operating the system. The other thing you can do is, or we have done at CSCS, you can try leveraging other tools, for example, Logstash. And here what is highlighted is, at a lower level for these tools and monitoring alerts, so you have thousands and thousands of error events, sometimes in a matter of some hours. And it's not possible, or in some cases it's not really necessary to react to that. So how you lift the abstraction of these levels, and that's why you have to come up with some of the custom solutions to gain knowledge from these error messages. I will go very quickly. So we have, for the network part, Chris has wrote many errors and logs. You have UFM. So this is my proposal. It could be considered as a very crazy idea, but I'm going to present it as EVA, because again, it's a community-oriented effort. So what I thought was, because in HPC community, especially people who like to publish their system on top 500, green 500 and whatnot, we are usually driven by some list, and then we can do, and vendors can go a long way to help us achieve and accomplish some metrics. So I thought maybe we can take some examples for top 500 systems in the notion of network and resiliency. We can include 5 best practices, and we can create a list where we specifically talk about how services are being offered on those systems. And to top it off, I said we could consider kind of an energy star rating for the robustness of services across multiple systems, and then users can have an idea how systems are being run. Right now, this is just an idea. It would need a lot of work and a lot of community effort. So if you have other ideas, or if you have some other, or if you use your own tools and resources to address the issues I mentioned in my talk today, please come forward and talk. So first of all, there should be zero or no, or really little overhead for making such a submission to a list like that, because otherwise people won't do it. Because there are too many 500 lists around, if you ask me. And what we could do, we can ask for some common metrics that could maybe collected as part of a top 500 run, so that should not be an additional effort. We can think of known errors or databases, or we can think of, look for practices that are used in different environments such as cloud. Or we could leverage other approaches. So how many of you have seen this thing before? This picture? Really few. I thought there will be more people, because I know very little about this thing. So, but there is a message. So I have started reading up. So this is this OpenStack, the idea of building the cloud provisioning solution, and it has different components. And these components, they use a common language to communicate or show APIs to each other. And if I'm probably not presenting it right, then, but the thing is, in this community, because we are not thinking of HPC in a widely distributed environment, they worry about resilience, or they have been worrying about it for quite some time in a high availability environment. So what I did, I looked up for some of the presentations that were given at these OpenStack summits. Some were really interesting, but I was kind of surprised that it's, again, because it's an old concept, so nothing, the ideas they are presenting are not different. For example, if you go and look up for this presentation, they introduce this idea of checklisting between different entities, which is kind of the regression concept we are trying to use. The other thing I liked it is wrecking crew. So the idea is you have to break it to learn how to fix it. And then there are other component by component analysis approaches which are kind of similar to hierarchy. So I think we can learn or leverage a lot from existing approaches. Then within OpenStack, some components, especially widely used, the compute engine, Nova, they have a draft for introducing high availability feature. There are some guidelines that some of the distribution put out, and there could be more. So the idea here is no need to invent from scratch. In fact, I was kind of surprised when I found this book, and this title is that in a distributed environment, everything can fail, and most failures are on network failure. So the idea is you design your applications thinking of a failure. And in HPC, we probably not tell our users that much that often, because we do not have underlying resources to help them migrate anyway. But to me, it's kind of an interesting concept that you at all the level of a stack, you think about failure all the time and migration. So what do we do next? It's very, from a technical point of view, it's easy or relatively easy to talk about resiliency. But from a cultural or investment point of view, these concepts are really hard. Because you need to ask people to do work which will not result in performance improvement. I mean, we are in HPC, in an HPC meeting. We have to ask them to document. And then you have to think about staffing consideration and SLAs and cost. So these are really important considerations, and I don't want to kind of ignore these things. What we can do as a community, and especially in this community, and that's why I ask you, is share your stories about these experiences or your tools or your practices. Happy ones and the ones that may not have ended very well. I would encourage you to give me feedback on Robust 505, or if you think that it's a very bad idea, I would also like to hear. And then I would invite HPC Advisory Council to take a leadership maybe on this issue, and see in subsequent meetings if there could be some momentum or some focus on this topic. Again, since I couldn't go through details on some areas as I was hoping to, so if you are interested in specific areas, please talk to these ladies and gentlemen if you see them here, and thank you. I think I am.
Any questions for
2 minutes. The first coffee break of the of the meetings. Yeah.
I really liked your concept of the rate of change being slower. I mean, for your physical environment, that probably outlasts 2 or 3 generations of compute. But you forgot the one major rule of operations. The big rule is don't make any changes on Friday.
But yeah, that could change depending on which part of the world you are. So yeah, we can make that rule, but with some flexibility. Okay. Thank you.
What was the name of the book that you mentioned?
It's Resiliency and Reliability on Amazon Web Services. Yeah. I haven't read it. I just read the
actually, a more serious point. I noticed you were talking about the metrics here, the 5 and 5 project. My last job, I had to prepare a report every week on how many useful CPU hours jobs are being run for as a ratio of the overall CPU hours. Sometimes I was getting 90 to 95%, which I think is very impressive. It may be commercially not possible to reveal those numbers, but if you've got a reliable system that will be running user jobs at a high proportion of the time, and that I think is a very good metric. If you've got a system which is unreliable and crashes, you won't be running so much. I don't know how many people would be prepared to reveal those figures.
Hands up, revealing it.
Yeah, I do not have a political kind of official statement, I should say, but I think if we are serious about that, then we should be open to, because you can improve on something or find a solution if the first step is to recognize a problem and then the extent of problem. So I think as a community we have to come together to be able to come up, okay, what is the extent of this problem, as you say? Is it 5%, 50%? And then people will invest in a solution. Yeah.
Perhaps a remark. Really find the value of because the top 500 really want to fix something. The reason why we design unresilient systems to get on the list, to get through funding from politics, and I use this set up to fix our phones. It's loading operations per month, not per second.
I mean, so my intention is not to change top 500 because so many livelihoods and so many projects will get in jeopardy. My idea is to capture something more than, as you say, I mean, sometimes we have instances where sites have published top 500 number, but it takes them 6 months to a year to get users on that system to be able to use those systems. And I want to capture that part together with and then, because then it would reflect the way people write procurements, the way vendor or sites also prioritize what gets to be done first versus later on. Any other? Okay, thank you.